Yes. Hey folks, and welcome back to another Billet Labs build. Now in this video I'm going to be building myself a water-cooled PC. And normally what you do at the start of a build is accumulate all of your PC components and then decide how to fit them together. But what I've been doing for the last few weeks is accumulating various obscure plumbing components made of brass and copper. I particularly like this giant piece of 54mm copper pipe. And I've also spent £344 on 4 small industrial fans, which are completely insane and absolute overkill, but that's kind of what we're about. I've also got this analog temperature and pressure gauge, so that's going to add to the kind of steampunky look. And what I have in my head is maybe the most ambitious build that we've attempted so far, particularly in terms of the plumbing, as you can see by some of this stuff, but I'm so excited to get going with it, so let's do it. So, what is this PC for and why do I need it? Well, I do a lot of 4K video editing now. I also do a lot of 3D scanning work through my other business, as well as a good amount of CAD work in Fusion and Blender for my mechanical puzzle company. And I've been doing all of that on this little thing, which I bought on eBay about 6 years ago. It's got a Ryzen 3600 and a 3GB GTX 1060 in it, so it's very out of date, and a lot of the stuff I'm doing, I'm finding that it really is struggling and taking longer than it needs to. But what sort of thing am I going to be building? Well, desktop space is very important, so ideally I'd have another small form factor PC about this size. But what's even better for desk space than a small form factor PC? A wall-mounted one. And now, all of these parts have arrived. So we've got a 9950X, that's going to be awesome for video editing. We're using a 3090 Ti because we have one lying around. We've got 64GB of RAM, 8TB of storage, 850W SFX power supply, and a Strix B650EI motherboard. So let's start planning out the build. I've cut to some MDF to size. This is just to lay everything out, and then we'll probably swap this for some steel or aluminium or something like that. And the rough idea I have is GPU here, motherboard here, power supply up there, pump in here, gauge here, lots of plumbing joining everything. This is going to be a reservoir running down the side, and then radiator and fans on the top. Now the thing about any open air build, especially a wall mounted one, is that you see everything. And I really don't like the look of pretty much all of this, other than these two bits. But it's all got this kind of angular black gamery aesthetic, which is not really my thing. So I'm probably going to spend a lot of time working through all these components one at a time to improve the look of them. Maybe make some custom enclosures or shrouds for them so that they really match the pipework. But for now, I'm just going to get the easy bit done, which is to fix them all in place so we have something to work around. And everything that's being mounted here is so that I have something to plumb and wire around. It's not necessarily the final way it will be mounted. I'm definitely not going to have the motherboard on these lime green standoffs. I just need it in some sort of fixed position. And these machined power supply mounts I actually had left over from our boiler build, so they just needed a small amount of modification to fit. Now the wiring is something I usually leave to the end of a build, but because we have so little depth to play with here, I'm planning that out now, as well as some other cutouts in the panel, just so I don't get caught out later trying to run 50 or so cables through a gap that doesn't exist. And I want to be cutting out as much as I can because I want to see the wall through here. I don't want it to look like a big square panel that's been stuck on the wall. And I'm not cutting all of these red areas out yet, because keeping them there is going to help the fitment of some items that we haven't mounted yet, and just help maintain the structure of the panel. And then I'm plugging in all the cables just to check that they fit where I was hoping they would. So everything coming out of the power supply is just bending directly down and underneath itself, so I need to check that there's enough space there. And then any cables that are the wrong length, I'm just measuring how much longer or shorter they need to be. And even though we're going to be leaving the wiring for nearer the end, we have done all the structural changes that we need to do to the panel to allow us to be able to wire it later without having to modify this later on. Which means now it's my favourite part of any build. We're going to get plumbing. But obviously to do that we're going to need a water block for the CPU. So we're going to be using this, which is our prototype Billet Labs CPU water block. This has been in development for over a year now. It's taking far too long because we don't want to release it until it performs as good as the best water blocks in the world, which it nearly does. We're almost there with it. First thing I'm actually going to do is just get this RGB cable out of the way, because f*** that. And it actually took me well over an hour just to mock up the first pipe run, because all these pipes are going to be running parallel to other pipes. So without having the first pipe in place, it was really, really hard to get started. So I've started with the easiest pipe, which I think says a lot about how hard this is going to be. But this is the first half of it, so I've got to stop putting it off and just get on with it. Let's go. Bit messy, but honestly it's not bad. That goes in there, and then I need to make this link up with here. I'm having to do this in 3 parts just because everything moves so much when there's a pipe this long and unsupported, but hopefully it'll work in the end. Pipe 1, part 3, and I'm putting a sacrificial wet sock just over here so I don't remelt this half of here. It might catch on fire, but that's a risk I'm willing to take. It's alright, pipe 1 done. Don't worry, we'll clean it up later. It looks a bit of a mess. Okay, and does it leak? Doesn't seem to. Tastes like ah, God. Oh, that is pretty awesome. So next we're going to be joining here to the outlet of the pump. This is where I was going to put the dial, but I've changed my mind on this. This goes from 0 to 6 bar, which is way more than we need, and to 120 degrees C, which is way more than we need. I also think it looks a little bit too kind of colourful and childish, so I've instead got this temperature gauge that goes to 60 and this pressure gauge that goes to 1 bar, which is about 14.5 psi, and I think the two of them together looks a lot better than that. But it makes the plumbing a lot harder. The temperature gauge just slots in after we've attached this brass piece, but this one is one piece, so I'm going to have to tape that in when I finally do it to seal it properly. It's gonna be so cool. That was the messiest one so far. There's so much thermal mass in this brass piece that by the time that's hot enough to solder these two together, everything else is already up to temperature, so all the flux starts boiling away. So we got this pipe now in these 3 pieces, and we need to join them all together, and that's going to be the hard part, I think. Got my safety socks. So this last join I'm actually going to do in situ, which is a bit sketchy, but I'm just going to get much better accuracy because it's going to be so hard to get these lined up and then take this entire thing off without it twisting slightly, and a fraction of a degree is going to stop this fitting completely. I think if I just drape this over it, then it's going to be fine, but we'll see. If it starts catching on fire, then I'll stop. Oh, stay cold, stay cold. So next up we're going to make the reservoir that runs down the side here. So we got this 54mm copper pipe, which is going to make up most of it, and then at the top we're going to have this And then at the bottom, this and this reducer piece. And then we'll have a nice drain at the bottom that's going to be lower than everything else. But firstly, I'm not a massive fan of this octagonal top, so I'm going to grind that down into a circle first. That's nice and round now. 19, 190 plus 30, 1.5, 63, 190 plus 63, 253. 253, yeah. Cool. It's a bit not round, so this is kind of a pain in the ass. That seems about right. Nailed it. And I really should be using map gas, but I'm not. Oh, it's going. Not going around this side. Maybe that's what happens with big pipe. I don't know. There we go. That could have gone a lot worse. Pretty sure it's all airtight, watertight. And the inside actually looks quite neat. All those drips are just flux. Then I'm laying out the pipe runs for the inlet and the outlet of the reservoir. And I think I'm going to do it in situ again, even though it was a bit sketchy before. Safety socks. I think we're good there. Good to be extra safe. It's on fire. I don't want to set the fire alarm off. Let's go that way. So that should mean that now I can take this away and that is floating there. Love it. It is starting to take shape. Whoa! Forgot that wasn't attached. And then Sam was in for the day and hadn't seen any of the progress of the build so far.
What are we going to see? Oh wow! It looks like World War II kind of backpack armour. Those are large. What is this? Thought so far. This is a beast. It does look a little bit like a flamethrower almost.
And speaking of flamethrowers, had our first sock tragedy. Nice. Pretty solid. It's getting there, folks. Starting to take shape. But we can't do any more plumbing until the radiator arrives, which I've been waiting for about 2 weeks. And the radiator has arrived. This is the Bixby copper radiator. And it's quite an unusual size for a radiator, which is why we had to buy it from China. This is a quad 80mm radiator, because while this is a small form factor build, the most important dimension to be small is the projection away from the wall. So having that 80mm means it is barely going to stick out any further than the other components. And right now you might be thinking that this isn't nearly enough radiator to cool 600 watts worth of PC components. And yeah, you kind of have a point, But remember, this isn't a gaming PC. It's not going to be running a sustained 600 watt load. If it does run at full power, that's going to be happening for a few seconds at a time. And with it being water cooled, those heat spikes are going to smooth out. There's also loads of water in it with the giant reservoir and all the piping. There's a huge amount of thermal mass for it to warm up. We've also got ridiculously overpowered fans, and the radiator is at the top, exhausting upwards, so we're going with gravity, and there's loads of airflow all around it. But in summary, I'm making the decision to use this radiator because I prefer the look of it. And if it ends up running hotter than I want, or the fans are on full power all the time, then I can do something about it at that point. I can put in another radiator, or do one of many possible things to improve the thermals. But for now, I'm hoping this will work, so this is how I'm building it. So in places where we've got like two pipes running parallel going around a bend, there's actually two different radii of bends that you can get. So you can see the difference between those two. So I'm just making sure I put bigger radius bends on the outside because I think it looks a bit better. And this pipe is actually a perfect example of a bit of plumbing that wouldn't be possible without the extendable telescopic fittings, because we have a rigid pipe that touches the bottom of the radiator and then goes into the top. So if these didn't extend out, we would actually never be able to screw that in. I almost forgot the little drain plug here. So this is the last bit of plumbing, hopefully. But before we can call the plumbing done, we need to clean up the outside of these pipes. The surface of them is already tarnished from the heat, and there's lots of big blobs of solder all over the place. And the next steps really prove that you don't need to be a neat plumber or a neat solderer to make a copper water-cooled PC. You just need to have the patience to fix it afterwards. So the first thing I usually do here is just find any of the really big blobs of solder, and then using a carbide Stanley blade, I'll just slice them off. Then I'll use various metal files, followed by various grades of sandpaper. And personally, I actually find it much easier to use nail files than sandpaper, because these pipes are often quite difficult to hold or clamp somewhere so that you can use sandpaper on them. And I find this easier, so that's what I use. So here I've used 250 grit, 1000 grit, and then 4000 grit. I then use a rag and some polishing compound, and here's what the first pipe looks like all cleaned up. Shiny. And then I just had to do exactly the same process for every pipe. Some of them were straight enough that I could use my polishing wheel to speed things up a bit, but obviously because of the complex shape of a lot of these pipes, I couldn't do that, so it was a very manual, very slow task. And I'm just slicing, filing, sanding, and polishing. But it is messy work. Oh god. Really happy with that. Plumbing. Done. It's looking pretty awesome. But as I said earlier, I want to do some customization to the GPU, power supply, motherboard, and the radiator. So let's start modding some of these parts. So I'm stripping the paint off this radiator, and this process really reminded me why I hate using Paint Stripper, because the footage you're seeing here is 3 hours of sped up footage, so it definitely slowed the process down a bit. And you might be watching from the USA or from another country wondering why I'm not using better Paint Stripper. Well, all the good Paint Stripper is illegal here, so we have to use this like non-toxic stuff that just doesn't work on half the paints you use it on. So I ended up scraping off the rest and sanding it using Dremel wheels, but eventually got it back to bare metal. And I think it looks well worth the 3 hours it took me. We're going to look at the fans next. So this is a Sanyo Sunace 80T. They cost me £86 each, and the main reason I bought them, other than being insanely powerful, is that they have a metal casing. Now these are just going to sit on top of the radiator like this. However, we don't need these 4 screw holes on the top, and I kind of like the idea of grinding the top into more of a circle so it looks like we've got 4 individual throttle bodies like you get on a modified car engine. So I'm going to try trimming off this top edge and also these reinforcing kind of ribs here. I'm a bit nervous because if I mess this up, it's quite a lot of money down the drain, but I've decided to do it, so we'll see how it goes. So I have done this corner here, I think it will look good. But I just need to do this 15 more times. And then 3 hours later, here is the result. And they're looking exactly as I hoped. I've then 3D printed these gaskets in TPU to give a good seal between the fans and the radiator. And then I'm bolting them on using these brass dome nuts and washers. And it's almost there, but I'm not a big fan of these stickers. So I've got these little 1mm brass discs laser cut, which I'm just giving a quick polish before gluing them on in place of the stickers. And there is our finished radiator and fan assembly. I think it's come out really nice. We've got 4 metals here, so we've got brass, aluminium, steel and copper. And I think they all go together really nicely. Now, a lot of people have been saying that I'm crazy trying to use these fans for this sort of build because they are incredibly loud. However, I'm hoping that when the PC is at idle that we might be able to run with the fans off entirely because the radiator is pointing in the right direction, so the gravity is going to be lifting the heat out. Thought you might want to see what they sound like when I put a constant 12 volts to all of them. And honestly, other than them being metal, the main reason that I want these fans is so that when I press the power button, it's a bit of like a theatrical experience. So all the fans just go like, woo! Because I'm a child. But this is what they sound like. I'm gonna put the microphone here. So yeah, pretty loud, but that is sucking air off the table. If I lift that up, that's actually not that bad. I mean, yeah, it's not quiet, but there's so much air coming through here, that's crazy. I wonder if I can stick it to a surface. Not quite, it's kind of sucking itself to the wall, but I don't think it will hold its own weight. Oh, that is nice though, it's hot today. But yeah, happy with that. I think these fans will make up for the small radiator. Now onto the motherboard, and I generally find motherboards to be fairly ugly, obviously with the exception of our beautiful copper water block, but otherwise there's not a huge amount I can do here to improve the appearance of the motherboard. But something I do like is shiny, polished metal rather than metal painted black. So there's a heatsink here and a grill, which I can remove and polish. Shiny. And I think that makes it look just a bit more like Billet Labsy, a bit more our style. And then the other thing I don't like about motherboards when they're in open air builds is that you see the edge of the sheet metal of the I/O panel and the edge of the PCB, and it just looks a bit unfinished. So I've modelled up and then 3D printed this kind of skirt, which acts as the standoffs for the motherboard and then just goes round the edge to cover up the edge of the PCB. And I think it just makes it look, you know, a bit more finished. And then I'm using brass dome nuts and washers again, and that's the motherboard mods done. And next up is the graphics card, and we've already got it in this EK water block. Now, no offense to EK's designers, but the look of this thing is not what I want for this build. So after some careful measuring, I've had this 3mm brass plate laser cut. And the laser cutting leaves quite a rough edge, so I'm just using my Dremel and various other tools to smooth that down and make it nice and shiny. And I decided that I want this thing to look like a mirror, so I wet sanded it to 1000 grit, then 4000 grit, then used some polishing compound on the surface. And it looks a bit plain, so I've got some other accessories. I've got this 8mm thick laser cut piece of aluminium, and also this radiator thermometer. And again, the edges of this laser cut piece are really rough, so I'm just smoothing those down. Then because I'm gluing these together with epoxy, I'm just roughing up the surface to give the glue something to stick to. Then I'm just filling it with a load more epoxy and making sure the temperature gauge is perfectly aligned, otherwise that will annoy me forever. And this epoxy is rated up to 85 degrees, so that won't be a problem. And I realise this temperature gauge is just measuring the back plate of the GPU, which is a fairly arbitrary temperature. I'm mostly putting it there to break up the flat plate of brass and just add a bit more visual interest to the overall design. Then before I can attach it to the water block, this EK logo is unfortunately sticking out very slightly, so I'm just getting that out of the way. Sorry, EK. And I'm attaching it using more brass dome nuts and washers, and then some slightly larger ones to attach to these standoffs, and that is going to be how the GPU is fixed to the panel. Well, that is the shiniest and probably the heaviest GPU block I have ever seen. Love how that's turned out. But that's now really drawing attention to how bad the power supply looks, so let's sort that out. And here it is, a nice boring black box. So I'm resorting to the same thing that I did with the GPU, which is to cover it in a big slab of brass. But once again, I think that by itself is going to look too plain, so I've bought a voltmeter. And obviously anything that I'm going to measure is either going to be 12 volts or 240 volts. But I just thought the needle moving when I press the power button will add a bit more theatricality to the turning on of the PC, and it'll just be fun. So I'm modifying it with the aim of putting it inside some sort of metal enclosure and mounting it to the front of the power supply. But at some point during my modifications, I broke it. I broke the voltmeter. As I was doing it though, I decided I didn't really like that voltmeter anyway, so I've ordered another one. It's coming tomorrow. Right, it's tomorrow. Got my new voltmeter. It's pretty huge though, so we're gonna have to do some more intense modding. Hey! It's too big, sticks out way too far, doesn't look right, so I'm gonna have to think about that. That's not going on there. But doing that has made me realise something I can do to these two gauges, so I'm gonna do that now while I think about what to do with the voltmeter. Hell yeah. I'm so happy with those copper dials. I wasn't expecting the soldering to look so neat. And while I continue to make a decision about the voltmeter on the power supply, I'm actually going to work on the power button, and I've left a space for it down here. Now I'm very proud of the power buttons that I've made on our previous builds. So I need to make sure that the power button for my own PC really lives up to that. So I've bought this big industrial switch. It's backlit, it's yellow, and it's got quite a satisfying click. And I think it gives the right sort of retro look. It's the colour of like a filament bulb, but obviously it's huge, and I don't want the enclosure to be this big. So it's got these weird connectors on the back. This one is the switch mechanism, and then this one is just the light. So I'm now going to modify this. I'm going to keep the light section of it, but the switch bit I'm going to swap for this little micro switch, which has a bit of a nicer click. It's much smaller, so let's do it. And just testing continuity, and then running power through it. Yes, I think that's the perfect amount of brightness. I didn't want it to light up too much. I love the colour as well. Okay, power supply, volt gauge, attempt 3, and I've just rebought the initial voltmeter that I bought at the start. The reason is almost all voltmeters, like this one I tried to use before, are so deep that they're going to end up looking ridiculous on top of here. This, as far as I can see, is the shallowest analog voltmeter in the world that exists. So I don't love that it's square, but I'm going to make it work. Nice. So I am pretty sure that we have now made everything that we need to make, and it's just a case of cleaning everything, wiring it and assembling it. But there are some cutouts I haven't yet done in the MDF backplate. So what I should really do is cut out all those bits and then do a test assembly to check everything works. But I'm not going to do that. I've taken a bit of a risk and already measured everything up. A week ago I ordered this. And this is the main panel that everything's going to mount to. It is 5mm thick aluminium. So first thing I'm going to do is give this a very thorough tidy up, because the edges have been laser cut. It's very messy, everything's very sharp, the holes are terrible. Yeah, you know the drill.
Let's polish the surfaces.
Oh yeah! It's not quite a mirror polish, because that would just be impossible to maintain, but it looks shiny, and that is what I'm going for. As of tomorrow, we are finally actually building this PC. No, we're actually not. There are some bits that I'm still not 100% happy with. Been thinking about it last night. The motherboard doesn't look as good as it could. This bit is a bit like a box on top of a box. It needs a little bit of something extra here, and maybe something on the GPU plate as well. I'm just going to do a few final little tweaks, and then we will assemble it. So firstly, I've 3D printed a few bits, but I don't love that they're black plastic. But luckily, my other business actually makes this nail polish that has aluminium particles suspended in it. So you can paint it onto normally your nails, but in this case, the PLA plastic. And then once it's dried, you can sand it and polish it just like you can a real piece of metal. And the end result almost looks like a piece of cast iron, which I think nicely finishes off this gap around the thermometer. And then I'm using some scrap aluminium sheet that I had to make a few little shiny flourishes. And the idea behind these additions is to counteract any imbalance that I see in the design of the overall build. So the motherboard, for example, is black and has lots of angles, which doesn't match the more minimal handmade nature of the rest of the build. So I'm putting on a piece that has the angles but is also a handmade piece to try and tie those two styles together. And if there's an area that is overly square, for example, like the power supply, I'm adding on a piece with some curves, and that should hopefully blend that in with the rest of the build a bit better. So while it might seem that I'm sticking random shiny things in random places, there is actually some thought process behind it. And the general aim is that when you look at the PC, nothing stands out as looking out of place or weird in any way.
Alright, let's do it.
So I got the panel on these temporary feet, just so I can move it around without scratching it. I'm going to start by laying out some of the wiring. Yay. So we've ordered these custom length cables from Cable Mod, because I, would you believe, don't particularly like making custom cables. And the first thing I'm going to mount is the GPU. So I'm just giving the water block a rebuild, check that the thermal paste and the pads are all good. And this 3090 Ti is actually the same 3090 Ti that we used to design our monoblock a couple of years ago. It's also the same card that went to Canada and got lost for a couple of months in the LTT warehouse. And then once we got it back, we managed to lose it in our own warehouse. But our warehouse is just a single shelving unit, so I'm not sure how we managed to do that. But for me, this card has some provenance behind it, so I quite like that I'm using it in my own build. And I'm using a thermal pad between the block and our brass cover, as well as the block and the back plate, just to thermally link everything together, which might help a bit with the cooling. And there is the first cable connected to the first mounted component. And the next one to go on is going to be the motherboard. So we need to build that up with all its components, and one of the M.2 ports is on the back. So I'm putting this 4TB drive there, and then the other one gets attached between these two heat sinks on the top of the board. And because I have a single-sided drive, the thermal pads on one side weren't touching, so it just took a bit of figuring out the best way to keep that drive as cool as it can be.
That doesn't look right.
This is why you read instructions. So this thermal pad is actually not getting used. I'm going to put another one in just for overkill. Yeah, that's some good squish. That's better. And then for the RAM, I've got this 64GB Corsair kit. And for the CPU, I've just been using this spare 7600 just to mock everything up. So I'm taking that out, and in goes the Ryzen 9 9950X, followed by this contact frame. And now we get on to the custom wiring, which is the bit I was dreading the most for this whole build. And I'm not going to make you watch it all because I didn't even film it all. But in summary, the 4 fans, which are 5.5 watts each, are going to be powered from 2 motherboard fan headers, each of which can put out 12 watts. Then the pump is going to be controlled by the third header but powered by the power supply. And that same cable is going to feed the voltmeter on the power supply. And then there was another custom cable to extend the connection for the power button and the light inside it. But as well as this, every other cable in the entire build goes underneath the motherboard. And because the motherboard has that kind of printed skirt, trying to get it mounted while feeding all the cables underneath for the final time and in a neat enough way was a job that would have been much easier if I had 5 or 6 hands. But eventually got everything lined up and got it screwed down. And then mounting the power supply was almost as difficult but not quite as bad, and just took a lot of fiddling and bending cables and pushing cables out the way, but eventually got that mounted as well. Even though I know it's all mounted, I'm still scared about picking it up. All good so far. Then the power button's going to go on next, and I've attached this fan connector to it, but it just needs a quick polish because I've been handling it quite a lot. And then next up is the CPU water block, and this has been tested several times, left on a shelf, picked up, handled a lot, so it needs a really good clean. So I'm just stripping it down to check the inside all looks good, and the fins are perfect, but I do want to reface the bottom of the cold plate. And then I'm reassembling it, and just giving the whole thing a good polish. Then next up is the radiator, which I'm just flushing through until the water comes out clean. And I've cleaned up the outside a bit as well. Then I'm building up the assembly again. So we've got the gaskets, then the fans, then the brass nuts on the top. And then the final bit of wiring is just going to be attaching a fan connector to each fan. And there's one done, and there's all 4. Then to mount the radiator, I've designed and 3D printed this little bracket, which just kind of wedges into the sheet metal on the underside of the radiator, hopefully without really disrupting any of the airflow underneath. And then that gets bolted on here just above the power supply and tightened up from the back. Then I'm joining the fan cables to the motherboard splitters, and it's a bit wobbly, but the other end will be secured by the copper pipes when we put the plumbing on. Now the plumbing has been handled quite a lot, so it's lost some of its initial shine, but more importantly we haven't cleaned the inside yet, and there's going to be a lot of flux and dirt and stuff that we don't want in our loop in there. And as much as I would love to clean it in my ultrasonic cleaner, it unfortunately wasn't going to happen. Don't think it's going to go, mate. So I went to see a guy called Kane at a local company who has a massive ultrasonic cleaner which removed all the gunk from inside the pipes. Now I just need to repolish the outside, and this is where I need to start wearing gloves for everything I'm doing because I don't want my nasty fingerprints to etch into the surface of the copper. I'm okay with it tarnishing and going brown, in fact I want it to, but I want that to happen at an even rate rather than having dark finger marks all over it. And I'm also prepping the pump, which is a 20 watt 4.2 DDC. So I've shortened the cable on that, and that's going inside our copper water-cooled pump enclosure, which should keep the pump at no more than about 2 degrees over the water temperature. And it's time to start mounting the plumbing. Now you might have noticed that the area where I originally mounted the pump no longer exists, it's just a cutout. And that's because I've decided to not mount the pump, I'm just going to have it suspended entirely from the plumbing, because I'm planning to run it at full speed. So having it not mounted at all will just keep it as quiet as it can possibly be. And then because I want the radiator fans to be linked to the water temperature rather than the CPU or the GPU temperature, I've got this temperature probe, and I'm mounting that to the outside of a pipe under the analog temperature gauge. So hopefully the analog gauge and the probe will be reading roughly the same temperature, and it'll also keep it nicely out of sight. And then with the pressure gauge, because there's no O-ring and the thread is parallel rather than tapered, there's no good way to seal this, so I'm just covering it in PTFE tape. And then finally, in goes the temperature gauge. It's very awkward to hold. I didn't really put any handles on the back, but it's pretty much done. There's a few little tweaks, like everything looks a bit kind of wonky because I intentionally oversized the holes when I transferred the dimensions from the MDF to the aluminium plate. So I need to sort of loosen all the nuts on the back and give everything a little tweak to get it looking straight. And then I need to leak test it. Oh my god, it's heavy. And I need to tidy up all the wires on the back with some cable ties or something. Right, so I have tidied up the back a little bit. I mean, I could spend hours doing this, but I still don't know if anything works yet, so I want the ability to take it apart without stripping the entire wiring loom apart. But I think it's good. I've also tweaked various screws and stuff, so it's straighter than it was. It's not perfect, honestly. There's a couple of bits where lines aren't completely parallel, but I'm going to live with that, which means we've got to start with some of the nerve-wracking bits. So I am going to leak test it now. I've leak tested all the pipes individually, and the only bit that leaked was this top cap. I had an O-ring on there. I've swapped it for a TPU 3D printed gasket washer thing. I still think that might leak, to be honest. But because it's a reservoir, it doesn't really matter, but I'd quite like it not to leak. Other things that might leak are the pressure gauge here, because that's just screwed in with PTFE tape, and obviously anything else might leak as well, so let's do it. Okay, we are just under 11 psi. If it leaks, that's really going to suck. But it won't suck quite as much as pissing water everywhere. The gauge hasn't moved. The gauge hasn't moved. It's been about 30 seconds. I'm going to go make a cup of tea. Right. That's gone down, isn't it? That's gone down. I can hear something coming out of here. I think that's it. And the gasket doesn't look particularly well seated. There's actually a little lumpy bit on here, so I've just smoothed that down. I'm just going to try it again with this. Because I retract what I said before, I'm not okay with it leaking because I want the pressure gauge to be moving. And there's going to be no pressure if air can get in and out. 9, like 9.1, 9.2 psi. Okay, you guys can watch that for me. Alright, it's been 5 minutes. Yes, come on! But we are not quite ready to fill the loop yet. There's a couple of final tweaks to do. Firstly, we need a logo. And secondly, we need to name the PC. And I also got slightly sidetracked and made this riser cable straightener bar thing out of a scrap piece of brass. And with that, the PC is finished, so now I need to wall mount it. straight? I think that's straight. Yeah, let's put some water in it. Right, so the plan is the water's going to go in the top here. Got this blocked off hose attached to the bottom. I'm going to disconnect the pump wire to attach it to this little jumper, which is attached to this 12 volt power supply. And I'm then going to fill up the reservoir. Once it gets above this pipe here, which is the inlet of the pump, the water should pour into the pump. So I'm going to pour water into here, and then once the level doesn't dip below here, I'm going to activate the pump, push the water around the system, and hope it doesn't leak. Which it shouldn't, there's no reason it would leak. Then I'm going to drain all the water I can out through this hose. I'm then going to put new water in and flush it through a couple of times. Hopefully any kind of gunk that's still in there will collect in this hose. Once all the water coming out is clean, which I'm hoping will happen straight away because everything's pretty clean in there now, I then have these little additives, and I only need a few drops to turn this distilled water into water that has biocide and anti-corrosive properties in it. So I don't need to drain all the water out, I can just put these little bits of the additives in. By the way, shout out to Mayhems, who, when I phoned the UK phone number, they actually had someone who was an expert and knew about these products who could advise me about how to use them, who answered the phone. So that's pretty rare. They're good, you should buy them. I don't know if they're actually any good, I haven't used them before, but the customer service was good. So let's get the pump wire out. There we go. Okay, we are now up to here. Oh, I'm just so nervous. Okay, so I'm going to turn this pump on, watch where the water level is, and continually top it up until it starts coming back out the top. It's going down, it's going down. It's coming out the top. Oh my god, that was the smoothest loop fill I've ever done in my life. Obviously there's a lot of bubbles and stuff, you can hear them, but they'll work their way through eventually. The pump is like whisper quiet. I'm so glad I didn't mount it to anything. I mean, you can hear air bubbles and stuff, but this microphone is right next to the pump and I'm speaking really quietly. So when I turn this off and then on, the pressure gauge is going to move. Ha! That's so cool. Right, the water's looking crystal clear. I think I'm going to drain what I can out of this hose and then fill it up again. Alright, flush number 2. Water's not moving anymore. Why is that? There we go, right. Now I can kind of tilt it like that. Feel the bubbles coming. So at this point I realised I had quite a major air bubble somewhere. So I ended up taking the PC off the wall to be able to rotate it around, but eventually... Right, it's been a bit of a struggle, guys, to be honest, but I finally got the pump flowing water all the way through. I've twisted it around a lot. I think we got all the air out of the system. Well, I got most of the air out of the system. Not hearing any bubbles other than the water flowing in the reservoir. So now all the water is flowing smoothly, so I need to add my additives, and I have inhibitor and biocide additives. So I need to add 2 drops of each of these per litre of water. That had 5 litres in. Of that 5 litres, 2 litres have gone in here, 2 litres have gone in there. So that's got about 2 litres, maybe more like 2 and a bit. So I'm going to put in 5 drops of each of these, and I can just do it while it's running. 1, 2, 3, 4. I wasn't watching, I might have done 6 there. 1, 2, 3, 4, 5. Right, last thing I need to do is swap this hose for this plug. I was going to put a tap on here so I could kind of turn it on and off, but I then didn't want like people turning it. I didn't want to knock it, so I ended up, probably not the best decision, just having a plug. So yeah, I've got a towel here. I'm going to end up pouring water all over the place, but I'm just going to have to do this as quickly as I can. It's pouring out. That could have gone worse. That wasn't bad. I hate this part. I'm actually like shaking with nerves. So the last 2 builds I've done, they both turned on first time once you forget me forgetting to turn the power supply on. So, plug's on at the wall. God, my heart is beating so fast. So when I press this, there's going to be like an agonisingly long 20 seconds, maybe that usually feels like about 5 minutes. At some point the pump's going to come on, at some point the fans are going to come on, at some point the motherboard fans are going to come on, and then hopefully something will come up on the screen. Okay. Oh my god. Okay. Fans are on, the pump's on because the pressure needle is moving. Oh, the voltmeter's on as well. That's good. Maybe I've got the source set wrong on the monitor. I actually vaguely remember having... Oh, what's happened? F***ing... Come on! Oh my god, that took so long. Oh my god. Right. Yes. It works, guys. Monday, I'm going to come back and install everything and test everything. Yeah. So I have installed Windows 11, I've installed all the drivers, done all the updates that I possibly can, and I'm ready to test Wally. However, we have some bad news, and that is that the water temperature sensor here that I wired in, I'm not picking up a reading from that. So I think I probably broke it while I installed it. I remember bending it more than I wanted to at one point, so I think that's what's happened there. I've got a new one on order, but that's not going to affect the performance, so the testing is all still going to be valid. It's just the fans might be going a bit woo 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 more than they need to. And speaking of the fans, I've got a few fan curves that I've been playing around with. Currently it is on silent mode, so these two fans are off. These two are running at 10%, which is 650 RPM, and you really can't hear anything at all. That's what you can hear. However, having it on silent mode, the water slowly creeps up to about 37 degrees and kind of hangs around about there. For a comparison, here is full speed, which is all four fans on 6700 RPM. And yeah, I would say that's probably too loud. With noise cancelling headphones in, that would be fine, but it's still kind of stupid. I feel like my neighbour will be able to hear this. So what I've decided to do for the sake of testing is to bring them down to 30%, which is 2,500 RPM, and then if the CPU or the GPU reach 70 degrees, they just ramp up to 100%. And this I find keeps the water temperature at about 31. So we're currently at idle, the CPU is at 42 degrees and the GPU is also at 42 degrees. So absolutely fine there. Our VRM is at 66, so that's absolutely fine as well. Both RAM sticks are at 38.5. The two drives are at 53 and 54, so also completely fine. And first test we're going to do is Cinebench. So that has started, the CPU is drawing 206 watts, So that seems pretty healthy, and it's currently at 65 degrees. So yeah, that fan spin up there is why the water temperature sensor will be a good addition to this. I'm actually live tweaking the fan curve here because the CPU seems to be just getting to 70. The fans come on full blast, immediately cool the water more than it needs to, and that's kind of making a self-perpetuating loop. So then that cold bit of water goes through the CPU, the temperature drops, and then the hot bit comes through, it goes up again. So I've added a bit more of a gradient to it, but I've been watching here, the water temperature's been on 34 pretty much the whole time, so this is absolutely fine. The CPU running at 207 watts easily has enough cooling with the fans at a manageable percentage. Okay, CPU stress testing done. It reached a maximum of 70 degrees and the water temperature is just slowly going back down. It seems to stop around 30 or 31. Okay, GPU time. So with the GPU, I've got the NVIDIA app and I've done the automatic tuning thing, which has increased the GPU tuning by 74 megahertz and the VRAM tuning by 200 megahertz. So we're running as well as we can do. And before I do this, remember that this radiator has less surface area than a single 240mm radiator. So if we can get this to not thermal throttle, I think that's a pretty good achievement. Let's do it. Okay, and our GPU is at 45 degrees and is pulling 458 watts, so that is pretty good going. Now the water temperature is creeping up, but very, very slowly. And obviously we have a massive amount of headroom with the fans, so this is still running with the fans at 30%, which is fairly quiet. I don't know, you guys be the judge. To me, that is fine. I would say that's about the same volume as my previous small form factor build that I had on my desk. Everything's pretty warm, water's at 39, everything feels at about 39 degrees, and GPU has just hit 56. I'm very happy with the performance of this so far. Obviously I could just put the fans on max and everything would perform insanely well. So the water is at 44 now, GPU is at 60, and I don't think it throttles till 83, so we've got miles of headroom still. We've been running Firmoc now for 19 minutes and 36 seconds, and the water temperature has been stuck at 48.5 for the last 5 minutes, as has the GPU temperature at 64 degrees. The fans are still running at 30%, and I'm very happy with that. So the last of the thermal tests is going to be the hell test. We're going to run Cinebench and Firmoc simultaneously. But before that, I thought it might be fun to watch how quickly this needle goes down when I turn off Firmoc and put the fans on full. Okay, Firmoc off, full speed fans, let's go. I thought it would actually move quicker than that, but the reality is there's about 2.5 litres of water in here, so there's quite a lot to cool down. Okay, let's re-engage the slightly more sensible fan curve. So the water is now back down to a Arctic 32.5 degrees, and it's hell test time. I'm curious to see if this tiny little radiator can stop the GPU and the CPU thermal throttling. So that's probably going to be nearly 700 watts. The CPU is pulling about 208 at full load, the graphics card 460-ish. Cinebench go, Firmoc go. Currently the CPU is at 71 and the GPU is at 51, and we are nearly 1.5 minutes in. So the CPU temperature is now starting to hit the steep upward curve on the fan curve, and the fans are getting to maybe 60% or so before they bring the water temperature back down, and it's been sitting at 42 to 43 for a few minutes now, but we don't need full fans for this, I don't think. Okay, so our cooling has definitely hit its equilibrium point because the water is at 43. As soon as it starts going to 44, that brings the CPU temperature up enough to spin the fans up. That cold water comes into the reservoir, back into the water temperature, and that brings it down to 43 again. So That is really awesome because the GPU is at 59, the CPU is at 82, and our fans are only at 50%. So we got so much headroom, and this is all through that tiny little radiator. Yeah, that's so good. It's a bit loud, but obviously once I've got the water temperature sensor, these fan speed spikes are going to be so much smoother. Okay, now we're going to have a bit of fun, and we're going to see what sort of performance this thing can give us if I didn't give a f about noise. So let's go full speed. I don't know what it is, but I kind of like it at full speed. I think a PC like this attracts the same sort of people who put a loud exhaust on their car, and that's me as well. So, okay, I think that's as cold as we're going to get it, and it is idling. GPU is at 30, CPU 39. While this is going, I think I want the Wally logo there. If I change my mind, I can put it back. So, Cinebench results. The GPU test got a score of 20,408 and the GPU peaked at 42 degrees. The CPU multi-core got a score of 2308 and the CPU peaked at 70 degrees. The CPU single core got a score of 139 and peaked at 54 degrees. Back to full speed. And 1440p benchmark. Let's go. Alright, we've got a score of 10,851 points, 180 frames per second. Now, even though this isn't a gaming PC, you probably want to see it play some games, don't you? So let's go with Cyberpunk. Right, we got all settings at max. We're on a 1440p screen and we're doing a benchmark. So the CPU is pulling about 78 watts, GPU 402. And we have averaged 57.58 FPS. I haven't done this benchmark on any other builds, so I'm not sure if that's good or not, but, you know, it's not a gaming PC, so it doesn't really matter. Now I've put the fans back to my slightly more sensible fan curve. I'm going to see how it handles a bit of running around in Cyberpunk without the fans on stupid mode. I mean, yeah, if I was using this for gaming, I'd probably be very happy with this. Got all the ray tracing things on as high as they go. GPU's pulling 357 watts. The CPU is at 70 to 75-ish. And our temperatures are very good. We are at 47 on the GPU, 53 on the CPU. Alright, that's enough of that. Honestly, I couldn't really be happier with how this has performed. It was never going to be a gaming PC. It's never going to be running the 700 watts or whatever it was that I put through it. And I couldn't even get anything to come close to thermal throttling, even during the hell test with the fans on like 30%. So what have we learned today? I think we've learned that if you need better cooling for your PC, you don't need more radiators, you need fans from a server room. Although for the price of these fans, you could probably do something a lot more sensible. But I love it. Every time I turn this thing on, it's going to be a fun experience. I just love the dials. I love that they all work. And then let's get on to stuff I would do differently or stuff I want to improve. Obviously I need to fix the thermocouple here so I can better control the fan curves through the water temperature. All the wires coming out of here, not a big fan of that. I think I might think about making some sort of shroud over them or some kind of pipe. I'm not really sure because I need access to all the USB ports in the motherboard. So if you've got any ideas on how I could improve that, stick them in the comments. Let me know what you think of the build. I can't wait to do some actual work on this thing. It's going to be awesome. And I think we're going to leave it there. So thank you so much for watching and you're all awesome.
Oh my word. Let's turn it on. The voltmeter. Oh, for guys, you can see the pressure pull up as well. The fans really start to work, don't they? Like the reflection on all the polished brass and such is so lovely. I love what you did with the logo. All the little like, the temptation to try and like,
Press stuff, yeah. So the Wally logo is magnetic, so you can move it around. I had it in the middle yesterday.
Oh my word. That is such a nice touch.
So I wasn't sure where I wanted it.
Yeah. So. Oh, it just goes. Okay, that's so cool. And we're all set up and it works.
Final thoughts?
Wooly is out of this world.
Nice. I love that.